All right, we're back. We are GAME3001. That's Game AI in the winter 2020 semester, and it's week 2, and we're talking about this little challenge I gave you guys at the beginning of class, which was make an enemy game object, and in the enemy game object, I want it to go back and forth across the top part of the screen, right? How do you do that? And the challenge I always get with students, by the way, we're using the template is going to be version 3. I'm going to be uploading or updating this template going forward. So you're going to see this template move to something else in the coming weeks with more functionality. I want to try and give you as much functionality as you need to complete your assignments. Okay? But before we get there, you need to know how to do the template. I'm just going to close the door. It doesn't matter how much functionality I give you if you don't know how to use it. And that's what this exercise is today. How do I use what I've been given to make a game object? So one of the questions I always get is, where do I start? I have no idea how to start. What do I do first? Even if I've given you a little a lab write-up, which I did today, and I said, hey, do these things, you still don't know where to start, right? So one thing I said was you need a texture, and I kind of put that up on Blackboard for you guys. So something that represents the ship. And right now, if you look at your project, it should be, I'm just going to look at my project itself. You should put it in the right spot. So that's like kind of the assumption. The assumption that it's going to be inside of assets, textures. And I have it here, it's enemy, it's pretty ugly. The enemy. Let me show you what that looks like. So again, I found this online, I modified it, or whatever, I shared it with you on Blackboard, but literally it's this little plane, okay? There it is, that's the plane. Okay, so that's the one that we're gonna kind of put up on in our project. Right now, when we look at our project as is, it's just that old project we did last week. Hopefully it's not gonna be too loud. Okay, it's like super loud, but that's the project. It's pretty simple. It's that little mail palette thing with the clouds and the islands and the plane. The plane collides with these killer clouds. The killer clouds are, I don't know, radioactive or something like that. They corrode the plane and destroy it. You run over the islands. Some man says, yay, right? And you drop off some mail. It's like a really silly game. It's my Hello World game. But anyways, so now we need to add an enemy, and I want it to be added at the top. But how do game objects work? Remember last week we described how the game object superclass is, you know, kind of what I've created, and I've made it so that it's a abstract class that you need to override, right? Remember that you cannot instantiate objects of type game object, but rather you need to create new classes that derive from the game object superclass. So that's the first thing you're gonna have to do. You have to make an enemy game object. However, enemy class, you have to also put it in the right spot. And unfortunately, it doesn't happen automatically all the time by default. And in our project, it doesn't. And again, this is a little bit by design and by accident. But let me talk about this. If I right-click on my header and click Add New Item, I'm going to add a new class. There's some options here. One of them is like class.cpp, right? Or this one, the class thing. If I did this, even if I change the location, down here where it says location, it shows me the location as my source files, right? Take a look. It shows me that template. And even if I browse to source files, so I go to template and I go to src, this is where your stuff should go. But if I use class, and some of you may have done this, and if I click add, right? Well, it doesn't care where you put it before. It just, you know, Visual Studio does weird stuff. So here, my class name, let's try it. I would put an enemy class, and you can see that it creates your enemy.h and your enemy.cpp. And the base class should be GameObject. You can do this. You can say like GameObject is my base class. Just type it in, right? Yay, oh, wonderful. And you can actually, you know, point to where you want this thing to go, right? My enemy.h, you can literally try and do this. I haven't found success with Visual Studio doing this anyway. Even if I try and point to it or whatever, it's not really happy with me at all. So if I go into courses and I go into our stuff and I go into the right space, which is template version 3, and let's say go into the SRC folder, and I want it to be here, right? By the way, notice that there's already a couple of these I gotta get rid of because I had them before. Let me just get rid of these things, and just that way, let's do it on the operating system. Hold on a second. Revamp. Just want to make sure that these aren't there right now because I already did this demo a couple times. So yeah, let's go back out and go back in, and you can see now that they're no longer there. And so my enemy.h, that's where I want it to go. I want it to go to, again, in my case, documents, courses, whatever. And I can swim there all I like. But even if I take the time to do this, and I go into template version 3, SRC, and click, yeah, this is where I want it to be. Yay. And I do the same thing for my enemy.cpp. I swim there, and it's got to go there, and I press save. And sometimes when I press OK, even though it'll create the class for me nicely, and it puts them an enemy here, and it puts another thing that's down there, sometimes it won't connect. And the way to check that is make sure that they're in the right spot. So go to your operating system, and then see that your enemy.h and enemy.cpp are in this right spot. If they're not here, right, like now they are, but if they're not here, then this will never work. Okay? That's number one. All right, so it kind of scaffolds it out for you, and that's fine. I'm happy with this. But remember what I like to do, I like to be extra careful, and it's not required. Once I have pragma once, it'll take care of it, but I also like to put in if not defined, kind of enemy. I want to put that in there. And then I want to define enemy. Again, this makes sure that I'm not going to reuse this H file more than once, right? And down in here, I can say that end if. Defined enemy. Again, this is just a kind of a convention that I use. I've always used this kind of way of doing things. So that's cool. And my CPP file. So here's my CPP file here in my sources, right? And you can see that in my CPP file, it just includes enemy, right? One thing to note is because I'm using ReSharper C++, it gives me this little squiggly down here, and it tells me that if I go here that, hey, maybe I want to generate my missing members. This is kind of a quick hit function. That's why I like refactoring with ReSharper C++ because it gives me extra functionality. But you can also type this on your own. So I'm going to click this. It's going to put up a little dialog box that shows me my functions that I want to override. Click finish. And when I do that, it kind of puts the functions in place where they belong, in the private area. I'm also going to have some functions in the private area. I'm going to have two of them. One of them is going to be called m_move. And the other one is going to be m_checkbounds. I'm using move and checkbounds every frame, but you could set this up totally different. So there's my little enemy class. The only thing I'm missing is my constructor and my destructor. Now again, there's things you can do with these things to optimize, but what I definitely want to do is generate all of these implementations. So kind of go here, generate implementation, and then do that for all of them. You can step through generating the implementation. It'd be nice if they had a quick way of doing this, so you can generate all the implementations all at once. But all I'm doing here is basically just creating the stubs inside of the .cpp file, right? So totally cool, to do it this way because it just reduces finger typing errors for me. You may choose to type it by hand if you find that that is something you enjoy, right? So there we go. So there I've kind of scaffolded out my class. And this is the base where you should start. You should just start by adding a class, scaffolding it out, and that would be the first step. Second step. So let's suppose I have this scaffold, but I don't know how my project links everything together. How does it bind everything together? Well, I want to get examples of maybe some other objects that I already have in play, right? For example, my island. Let's take a look at that. So I have my examples of my island.h. Here's my island.h. What does this look like, this island.h thing? Does it look similar to what I got? And yeah, it looks very similar. So I think I'm good from a .h perspective. But how about my island.cpp? Well, that's where we get some more implementation details. You can see I've got some stuff in the constructor. I've got some stuff all over the place. You know what? I'm going to use this as a template. And an easy way to do that is just pull off your island.cpp file and just make it so that it kind of hugs the right side of the screen here. And then I can see both my .enemy.cpp and my island.cpp and kind of compare what I need. So I probably need all of this. And what is all that, by the way? If I kind of pull this over, you can see that it does a couple things. I load my island. I use the texture manager to do that, the singleton. I resize. I make sure I check the size of my island by inspecting the texture and getting the width and the height. And I did this because what if I want to replace my island texture with something else in the future? I don't want to hard code it here. I also have a velocity and a reset function. I probably won't need the reset function for my enemy. I'm not going to reset. But there's also is colliding, and the type is what I have here, plus some kind of sound. I'm not going to make any sounds from my enemy plane for now, but I can probably grab all of this as a template. And again, I'm not talking about templates as in C++ templates. That would be a little bit outside. And you can see immediately that I don't have access to my texture manager, which means I need to include it. So include, game.h. There we go. All right, so game.h does this. You can see there's no reset function. Let's just get rid of that. And let's fix it so that I have everything that I need for my enemy, not for my island. So this wouldn't be island, it would be enemy, because I'm loading the enemy PNG, right? This one would be called enemy. In a future iteration of my code, I'm going to remove the strings and use an enum, because if I type this wrong, it'll never load. So I've kind of worked on that. Same thing with this. I want to use the enemy, just change some of these things up. I have a velocity, and the velocity vector is 0 and 5 on the x and y axis. We're using the GLM library here. GLM is a OpenGL graphics library, but it just does math. It doesn't draw anything. And so it gives us things like a math vector, like geometric vector x and y, vector 2. If it was a vector 3, it would be x, y, and z. A vector 4 is x, y, z, and w. Or you can also use a vector 4 for color, R, G, B, and A, right? But it gives us all this stuff, plus matrix functions, different mathematical functions, a bunch of stuff, and that I've included it here. Again, in future iterations, I'm going to try and kind of reduce, and I'm just going to make my own little vector class just to make sure that you guys have a handle on everything that's being done in there, and so that you can modify it. But for now, we're using the GLM library, which is really good, actually. So it tells us that with this vector, we're going to go on the x-axis 0, on the y-axis 5 pixels per frame. I think I want to go 2 on the x-axis, and I don't want to move down the y-axis at all, so I'm just going to leave that at 0. So that's the first thing. The other thing I want to do here is maybe set my position. I want to set up my default position, because by default, if I don't put in my position, it's going to be the top left corner of the screen. That's how it works. 0, 0 point is the top left corner of the screen, and then it's going to draw from there. So let's put a new position. I'm going to use a vec2 here, and I'm going to use the width and the height to give me a kind of a default position. So for the x value, which is related to width, I'm just going to put the half the width of my plane. So I'm going to say something like get width, right? Multiplied by 0.5, that's going to be the x value. And then for my y value, I'm just going to use the whole height. So I'm going to say get height. And this is just going to be the value that I'm going to offset from the top left corner. So in other words, if I start off at 0, 0, and I add half of my width, let's say my width is 40 pixels, that means I'm going to go in 20 pixels, all right, like on the x-axis. And let's say if I get height, and my height is 40 pixels, let's say, then I'm going to go down 40 pixels. So that's where it's going to be. By 2040 is where my plane is first going to be drawn. right? So kind of an offset from the top left corner. That's what this is, okay? So I've got my width, I've got my position, I've got my velocity, I've got this stuff. My constructor looks like it's pretty good. What about my other life cycle functions? Remember, I have a draw, update, move, and check bounds. I want to update these things. So how do I do that? So let's take a look at islands. So what does draw look like? Oh, okay. Looks like what I'm doing with my island is I'm getting the X and Y components from the existing X and Y components. I'm just renaming them to make them local, right? And then I'm using the texture manager draw function to draw my island, which I'm getting from the texture map, at the exact X and Y components that I'm at right now. That's what it's doing, right? That's what I'm drawing. And I'm using the renderer. So I can just pretty much copy this code. I mean, I'm not going to change anything for my enemy. Copy that into the draw. Just change this from island, because I'm not using the island texture anymore. I'm drawing the enemy texture, which I just loaded, right? So that's the draw function. I need to put something in update, and usually what it's going to be is I want to move, and I want to check bounds. I want to check my boundaries to make sure that I'm not out of bounds when I move, right? So I'm going to move my little plane. It's going to move from left to right, and when I get to the right border, I'm going to move it back this way. And that's the check bounds function. All right? So in my move function, instead of me reinventing the wheel, I mean, I move my island. Let's see how it moves. So going back to island, if I scroll down, hey, look at this. I have a little movement function. So I'm going to copy this part. I'll explain it in a second. And move it over here. All right, cool. Well, how does this work? So I make a new vec2, a new X and Y coordinate, and I just take my current position and my velocity, and I add them together, so vector addition, and then I get a new position. That's what's stored here. And then I pass that into the set position function that all game objects have, which sets the next pixel up. Right, that's what it does. So every frame, I'm going to get a new position. It's going to keep moving, right, every frame. Okay, that's what's happening, and we're going to add velocity to it. This is enough. I'm not going to even code the checkbounds function yet, right? I just want to see this plane on the screen, right? So yes, I've made a game object. I've got some basic functionality. I just want to see this thing on the screen, and then I can modify the thing. Because maybe I'm going to code too much. I'm not going to be able to test to see what it looks like. Let's see if I can make this work. So question, is this enough? Is this enough so I can see my plane now on my screen? No, right? I mean, you haven't added it. I haven't even instantiated it. I've just made my class. Once I've made my class, I need to instantiate an object of type plane somehow, and in the game, add it to the game. I haven't done that. This is just making my class, right? So let's just get rid of it and go to my Solution Explorer and pull up my game.h. Let's start there. So in my game.h, I need to add a reference in an include for my plane. So in this case, I'm going to say include, enemy.h. There's my enemy.h. So I include that because I just made that class. And then down below where I have all the other game objects made, now I've chosen to make them pointers, but you can choose not to. I'm going to make a new enemy pointer object. I'm going to call it member variable that's private pointer called enemy. All right, that's what it is. Okay, there's my enemy. It's not being used right now. And I want to take this enemy and then in my game.cpp start using it. So again, in my Solution Explorer, I'm going to go to my game.cpp file. There it is. And in my game.cpp file, you can see that there's a couple places I use it. I'm just going to change the scope. And again, these little drop downs allow me to kind of select my game class and then go to teleport pretty much or jump to any one of these functions. I want to go to the create game objects function. And the create game objects function shows me how I already create some game objects. Let's just make mine. So I'm going to say m_p enemy is equal to a new enemy class, an enemy instance. So this creates an instance of my enemy class and stores a reference, a pointer reference, to a memory that I'm allocating on the heap. That's what's happening. This is heap memory that I'm allocating, dynamic memory. I'm storing it, a reference to it here as a pointer, right? And I need to do this because if I don't do this, then I got no enemy. I got nothing, right? Now I could make it so it's not a pointer, but like I said, I'm using a pointer here. All right, great. So now let's go to the other lifecycle functions. There's render and update. Let's render it. Now this is very important. By default, order here matters. So if I draw my enemy before I draw my ocean, what's going to happen is my enemy is going to lie underneath my ocean, and we're never going to see it. Even if I add it in, I should add it in the right order. So it's got to be like, first I'm going to draw my ocean. That's kind of the first layer. Then my island, that's kind of layer 1, and my player is layer 2. Let's make my enemy layer 3, m_p enemy, and then I'm going to draw it in layer order. There it is. This is layer 3. So that's when it's drawing, but it's not going to move if I just do this. I need to go into my update function and then also update my enemy. And this is the way I set things up. Again, not an ECS, right? So if I was going to make an entity component system, then this is definitely not something that I would be doing. All right. Again, this is not supposed to be a game engine. We're just making a little framework for you guys to learn AI, but we're starting small and slow. Questions so far? Okay, so this should be enough. If I did everything properly with these changes, it should be enough for me to kick this off, see my little enemy plane go across the screen, but it's not going to bounce. It's going to keep going forever. Right? So let's see that happens. So I'm going to run this thing, and we're going to see that little plane is going to literally run off the screen. Let's see how this works. Well, it won't run. It's just going to move off the screen. That's really super duper loud, right? So I'm going to try and reduce that noise. Can someone grab the door for our friend, if you don't mind? I got something there. All right, so yeah, that's pretty loud. But let me just take that down. I'm just going to turn this up to whatever the noise is going to be. There we go. So one thing to note is, again, let's talk about some process. 1, I got the texture. I put it in the right place. 2, I made a class, right? And I made sure that class, had all the components. I compared that class with something I already had, and I said, well, I did it like this because I want to inspect my code, and now I want my enemy class to do this, whatever that is, right? Yay, and this is great, but we're not done, because remember, when I run this thing, it just runs off screen like this, right? It keeps going. I want it to bounce back, and I can do that in the enemy.cpp in my check bounce function. So my check bounce function, let's do it. I'm going to say that, okay, first I want to check the right boundary. And by the way, there's other ways to do this, even more efficiently than this. Let's check the left boundary as well. And so my right boundary check is going to look like something like this. If get position, because remember get position is a thing that exists for all game objects, dot x, the x-axis, is greater than or equal to the right boundary. Remember that the right boundary on my screen right now is 640 by 480. I'm kind of hard coding it at this point. So it's 640 pixels minus half the width of the plane. If it's beyond that point, well, send it back the other way. That's what I'm going to get it to do. So I'm going to say that if it's greater than 640 pixels minus half the width of the plane, the little enemy, then what I want to do is I want to set my velocity, right, to a new GLM vec2 object that's going to be minus 2.0f and 0.0f. Okay, so that is the right boundary. And the left boundary is very similar. The left boundary, instead of it being greater than, it's going to be less than or equal to, instead of 640, it's going to be 0 plus my width, half my width. So it's just going to look like that. And then I want to make it positive movement to the right. So that's the only change I'm making. Yay! Check bounds right, check bounds left. So what's going to happen is it's going to go to the right, and it's going to, hey, I'm at the right side. Cool. Change my velocity to a negative velocity. It's going to start going to the left. Hey, now I'm on the left side. Cool. Now change my velocity so it marches to the right. And it's going to keep on marching to the left and right forever. This way. I don't need a reset function because I'm not resetting my plane. my enemy. All I'm doing is just changing the velocity of my plane as I move back and forth. Let's try and see if this works. There we go, and bounce. And bounce.
Yay.
Right? And bounce. Right? Nice and easy. So that's what these functions do. All right, so like I said, like with all that explanation, you know, as an example, it's 12:49. It took me half an hour to kind of talk about how that works, me explaining it to you guys. And that's, you know, again, it's not unreasonable. 20 minutes, if you really want to, you can get this done. If you're making a very simple game object and you're going to make more of them going forward, 20 minutes is about the right time you should kind of think. 20 to 30. If it was 30 minutes and you got it done, that's still pretty good. But anything beyond 30 minutes, that means you don't know the framework. Maybe you don't know the process. You don't know where to start. You don't know what to do, right? And that's okay. Okay. I want to put this up on GitHub for you, so you have a reference to it. I'm not going to do it today because I want you guys to work on it on your own. But I will put up a reference to this code that I'm showing you right here after tomorrow. Tomorrow is when this thing is due, right? So, you know, early next week you'll see it up on GitHub. You see the solution to this challenge, okay? But I've given it to you. I mean, I've recorded it. So worst case, you just go back and watch the video. But that's good work for you. That means you've done a little bit of research. You've watched the video. You've tried to figure out how it works. And I'm okay with that, right? So again, steps. Make your enemy class. Once you make your enemy class, modify your CPP. Add a constructor with the right pieces, right? Make sure your draw function looks properly. Make sure your update is okay. Make sure your move function is working properly. Update your check bounds function. Once you have that, go into your game.h. Include the enemy, or whatever the game object is going to be called in the future. Then go down. Make sure that you have some kind of reference, whether it's a pointer reference or not. You don't need a pointer. I'm using it because I feel like it. But you don't need pointers. Now, if I was going to make some kind of enemy object pool, then maybe a pointer might be appropriate with some kind of vector. And then as I'm going down, you can see that there's some things I need to do. I definitely need to, if you look at the init function in my game object, my game init basically draws the window, and down in the middle here, I'm calling create game objects. This is a good indicator of where I need to put my other stuff. So in create game objects, you can see that I've already created some. Well, I might as well create mine here. That's what I did. Right? And then from there, I'm going to look at the lifecycle functions. The render function, where drawing order matters. Drawing order matters. And if you don't understand what I mean by drawing order, think about this as slices of textures, that one on top of the other, right? And I draw my first one, then I draw the second one on top of that one, and so on. So I layer my textures in the proper order. I can't draw my enemy underneath the ocean, or else it will never appear. The ocean will draw on top of my enemy, which is kind of dumb. All right, so that's this. And then I'm going to do the update function, which just moves my stuff around. Remember that in our framework that we're using, update and draw are decoupled, right? So that you can do update separately than draw. Okay. Questions around this little challenge we have? That should give you everything you need to complete your lab 1 with perfect marks, right? Remember, this is just a litmus test to see if you can do it, and also, are you alive test. If you're alive and you come to class, you're going to get perfect marks. All right? That's what I'm looking for. And a little bit of practice on C++. So hand it in. Now, I'm going to close this down, and then how do you submit? Let's take a look at the requirements up on Blackboard. So, Blackboard. Yeah, here's your lab. It says your enemy ship, it's worth 1%. It's due tomorrow at midnight. Great. It tells you what to do. And then it says in the bottom, a zip archive of your project file, upload it to Blackboard, ensure you remove the garbage files. What are the garbage files? The DB files and the IPCH folder. Where are those things? Well, if you look at your template, you can see that inside the .vs folder, I have another template, right? And inside that, you see that there's a v16 and a v15 folder. If I go to the v16 folder, I see that I have a .db file. Look at that. That's like 45 megs. I don't want that. And take a look at this. My IPCH folder, if I right click and do a properties, oh my God, it's like 334 megabytes. Don't give me that. That's going to even compress. That's going to be like over 100 megabytes. Guys, that's not fair. Don't kill me. Make my job easier. Kill those garbage files. And the way to do that is just like go to your browse.vc, right click and delete. And then right click and delete the whole IPCH folder. But please leave the .suo file there. It's for configuration purposes. So it's the solution file. Notice what it says. Solution user options. Leave that there. I don't want to go and monkey with my options again. Okay? So again, you can see that there's there. In V15, there's nothing because I've cleaned that out for you. But if you have something in there like a DB file and an IPCH file, get rid of those too. Right? And now you're ready to zip it up and put it up on Blackboard. And the way to do that, of course, is here's what I want before you do this. Make sure you put some comments in your code somewhere that says, hey, let's say if I was submitting, it'd be like, my name is Tom, right? My last name. And then my student ID is whatever my student ID is. Hey, that's pretty cool. Maybe the date might be a good thing. And it's for lab 1, some kind of simple comments. You know, put that in your enemy.h, maybe in your enemy.cpp, put it in those places so I know it's you, right? Once I have those comments, you know, you want to zip everything together and you want to call it your name. So let's say, for me it's Tom, my last name, and then maybe dash your student ID, whatever your student ID is, dash lab1.zip. Put it up. Please do not give me a RAR file. I will not accept it this semester at all. I'll just won't accept it. I'll say, in your comment, you're going to say, please replace with the .zip file. Will not accept .rar. Here's something else that I also want to warn you about. Some people, for whatever reason, they go down to the template.sln file and they right-click this template and they go zip, and they only zip up the solution file. Guys, you give me a solution file, that is literally nothing. It doesn't tell me anything about your code. I've got that many times in the past, and you're going to get 0 for this. You just give me your solution file. Also, for whatever reason, people go into the SRC folder and they just give me the enemy stuff. That's not enough. I'm not asking for that. I'm asking for the entire folder being zipped up and given to me. In future iterations of this code, I'm going to ask you for a link to GitHub too. We haven't talked about GitHub, but we're going to talk about it right now. How do I use GitHub to put this up as an example? Well, one thing to note is, and I'm not going to put it up on GitHub right now because you'll have, like, there's nothing for you. There'll be nothing for you to do after this, right? But one thing is that if I launch Visual Studio right now, and if I go back into that last template that I was just using, this one, a couple things. You're going to say, well, what happened? I just deleted all this stuff. Is it going to kill my file? Well, once I run it again, right, it's going to recreate that DB file and the IPCH folder. It's going to do that. It's going to recreate that. I just recreated all those folders again, right? Those are like intermediate files and stuff that it uses, so that way when it does building, it caches the build, so it's a little bit quicker on the next build. All right, the first build's a little slower. Great, fantastic, but how do I upload this to GitHub if I want to? Well, first of all, I highly recommend, if you're using Visual Studio 2019, go to Extensions and go to Manage Extensions. And when you click Online, if you don't have this one, type in the keyword Git. And you're going to see that by default, you can download the GitHub extension for Visual Studio. You may have already installed this when you were installing Visual Studio, and there should be a check mark if you did so. If not, download it and install it. It's the GitHub extension for Visual Studio. I'm going to go over how to use this extension later on next week as part of your lab, right? So I want to do that for you. You're also learning how to use SourceTree, if I'm not wrong, from Joss and other professors, or Gitkraken, any kind of user interface. It doesn't matter to me, but Visual Studio has Git and GitHub built in. There's nothing for you to do. Just download the extension, and you can, on the bottom here in Visual Studio, you can see that add to source control is a thing. And if I add to source control, I'm not going to do it this week. I'm going to show you how to do it next week. Once I do that, it's going to ask me to do Git, and then if I go into Team Explorer, I can put this up directly on GitHub with that little extension that I just talked about, this extension right here, which is the GitHub extension for Visual Studio. All right? So that is what I will be using in the future. But for now, all I'm looking for is a .zip folder of your entire project. Okay? Please, if you put this up on GitHub, right? The biggest problem with Visual Studio and putting it up on GitHub and giving me a GitHub link, I won't be able to run it. And the reason for this right now is because by default, and let's look at the project again. If I look at my solution, and if I go to my operating system files really quickly, my file system, if I go to my file system, you can see that the template itself has a .gitignore by default. And if I open up that .gitignore, I'm just going to use Visual Studio Code for now, so you can see it. The .gitignore actually ignores stuff to put up on GitHub. It ignores the debug folder. Well, yeah, in most cases you don't want to do that, but for me, I kind of need the debug folder. This is where I put all my files. And also, it also ignores the bin folder. Yeah, the bin folder has all your DLLs. So if you don't have those two folders, then if I download things from GitHub, it will never run. I have to just like copy from my stuff into this folder, and you know, it's an extra step. And so when I create my new template for you guys going forward, I'm just going to go into my .gitignore file and modify this so that because you know, Visual Studio and Microsoft give you this .gitignore file by default to be nice to you, but actually what they do is they control what goes up on GitHub too. All right, so yeah, so I mean, you have to modify these things, and I'm going to show you how to do this next week. All right, so difficulty again for this project, I'm going to have to tell you, from a D&D perspective, if I was playing Dungeons and Dragons, this would be a challenge rating 1 monster that you're trying to kill. Okay, really low challenge rating 1 monster. This could be like a little skeleton, and you've got your hero, and he's trying to kill the skeleton. And you know what the problem could be? You don't know that to kill a skeleton, because skeletons maybe have a resistance to sharp weapons, you need to use a bludgeoning weapon for this one, because this is kind of what we're doing. A bludgeoning kind of way of making a game object, right? So you don't use bludgeoning weapons and you get your ass kicked. Sorry to say it that way, right? But you know, it's okay if that happens, right? Because you've learned a little bit of things, and the next time around when I ask you to make a simple game object, you're going to be good to go. Again, I'm being facetious. I do apologize. But you know what? At the end of the day, it's going to get easier, guys. It's not going to always be tough, especially since this is not a framework, it's not a game engine, you know, and so on. Things that I've talked about before. Questions around making a simple game object, an enemy game object, or any other game object. I'm going to ask you to make more of them going forward. Any comments? Things that you could have done differently if you had known. Now that you've gone through this whole process with me. So you guys are perfect for the next one, right? Okay, challenge 2. No, joking. Okay, so that's challenge 1. Challenge 2 will be next week. Let's close this off, and I want you guys now to open up the new template that I've kind of put up on Blackboard. I gave you another template on Blackboard. It's template version 4. We're not going to really do too much with this one, but I want to show you some stuff that's in that one that's a little bit different. So in my template version 4, I want you to take a look at this. If I double click onto it, here's template version 4. You're going to see that I have this utility class. Okay, here's the thing, guys. You need to memorize all of these functions. I'm joking. You don't have to memorize any of these functions. These functions here, I've made a utility class with some simple math functions to help you with AI this semester. And I'm going to probably port these functions into a vector class of my own, probably next week sometime. Okay, so why am I doing this? So that way you guys can have a very simple way of a template to use to build your assignment number 1, which I'm probably going to release, like I said, tomorrow. Okay. So what is this stuff? Well, notice there's a couple of static floats. One of them is epsilon. And epsilon, I want you to think about it as a very, very small number, 0.000001. And you're going to like, why would I need to know that, Tom? And the reason why is because sometimes you check to see if a number is equal to 0 or less than 0. If you make it equal to 0 and it's very close to 0, like for example 0.00000001, it's not 0, right? So you're going to be like, well, that failed. How come it's not happening? It's not, 0. Well, sometimes with real number calculations, floating point number error, you don't get 0. You get something else, right? Especially when you do things like with delta time. Sometimes you get a really weird number, right? So how do you do this? Well, there's a function that we have here called sanitize. And if you look at that function, if I go to definition, what sanitize does is it says, okay, take a value, and if that value is greater than the negative epsilon, so 0.0001, and the value is less than that the positive epsilon, so this is negative 0.001, this is positive 0.0001, then, well, that value then is 0. It makes it 0. So that way, if there's any error, it wipes out the error, and then it makes it 0 again, right? And why do we do this? Because there is that kind of error when it comes to calculations of this type. So please use sanitize for that, okay? Also, there's other functions here, and one of the ones I want to concentrate on today is a function called lerp. And what is lerp? Lerp is something called linear interpolation. It's really between A and B. I should say between A and B. So linear interpolation, that's what lerp stands for. It's kind of a funny name, lerp. There's also slurp, right, for angle, anything that's on a, kind of an angular acceleration, right? If I want to do something on an angle or on a slope, that's what it is, then I can use something called slurp, right? I know it sounds funny, but lerp is one of the most common functions we can use. And if you notice, what happens is we have something called a t-value and then two floats, a and b. And what I want to do is I want to give it a value. The t-value is going to say, okay, how close am I from, if I'm starting at a, how close am I to b? If the value of the t-value is, let's say, 0.5, then I'm halfway. I'm halfway between a and b, right? That's what it means. If the value is like 0.1, then I'm closer to a. If the value is 0.9, but then I'm closer to b, right? And what that does is it allows me to mix or transition from one value to another value. And there's a great GDC talk that explained this. I put the link up on Blackboard. Now I can't play this while I'm recording because I'm going to record a recording. And that's just not good, right? So we're not going to do that. We're going to stop the video here. But I want you to go take a look at this video. Actually, I'll put it up in a second. And it is this GDC smooth step video that we're going to get into. So I'm going to show this video now. I'm going to stop recording this one. For next week, we're going to have another challenge before I stop recording. Again, one thing to talk about for the people that are in this course, please make sure that you get this enemy ship challenge done by tomorrow night at midnight. It's due tomorrow night. It's worth 1% of your final grade. It seems like it's low, but I'm going to do several of these over the course of the semester, so that way you have your little marks. I could also do some quizzes in class as well, in lab, but typically what I'll do with quizzes is I'll let you know. I'll say, by the way, guys, next week we're going to do a quiz first thing when you come in. I'll tell you that, right? There's no quiz next week, by the way. There's just another exercise, right? But if there would be another quiz, if I wanted to quiz you on something, it'll happen next week. I might also do a little poll in lecture. I might say, okay, so little poll in lecture, just for testing your knowledge. What, as an example, what is smooth step, which we're going to talk about now in the little GDC talk. I might quiz you on it, right? It won't be worth any marks, but it'll be good for you to check your knowledge. So when it comes to the tests, which is going to be a midterm, then you've already practiced. Okay, so that's what's happening. I'm going to stop recording now, and we're going to get into that little GDC talk that's up on Blackboard. And the GDC talk is actually really cool. It's called Math for Game Programmers, Fast and Funky 1D Nonlinear Transformations. I think it's a great little GDC talk on easing functions, which is really cool, and I think it's great to take a look at this. Okay, so let's just pause or stop the streaming now.